Hey y'all, now we're going to talk about how the Milky Way galaxy and other galaxies we think formed. So we talked about the shape of our Milky Way and the role of globular clusters. Now let's kind of put some of those ideas together to talk about the formation of our galaxies. This is section 25.6. How did galaxies like our Milky Way form? Galaxy formation. I'm determined to do a better video this time. So galaxy formation, this includes our Milky Way and others. Not otters, others. Okay, starting off with a bang. So we think, and there's a lot of questions, a lot of unknowns here, but we think that back in the day, initially, we started with a cloud of dark matter. That dark matter was there first. So initially started with a dark matter cloud. Okay? And then the first stars were those halo stars like the globular clusters. Remember we said that they were really, really old? So halo stars, those stars that are in our globular clusters that are orbiting around the Milky Way, that they were the first stars to form. So they likely formed first. And I think that this is a beautiful image here of what this might have looked like. That it just was clumpy and crazy and so many stars forming at the same time. So it's really pretty awesome to think about the very first stars forming. So we had a dark matter cloud. Then the halo stars likely formed first. Then we actually had the galaxies form. Spiral galaxies is what we're going to talk about here. So then we think that gas collected, because this is a messy process. We have gas and dust as well as the stars all swirling around. Then gas collected in a disk, right? Like the disk of our Milky Way, like the disk of spiral galaxies. And somewhere around this time, the supermassive black hole formed. Supermassive black hole formed. Now there are some questions about the exact sequence of events, right? And I'll have a video on the playlist which actually asked the question, which came first, the supermassive black hole or the galaxy? It's up for debate, but we're going to put it in this order, that we sort of have the disk and the supermassive black hole forming after the halo stars. And we think that before this all happened, that we had these things called proto-galaxies. And the disk actually grew or formed from proto-galaxies, which were lumpy, irregular things. So disk probably formed by the merger of lots of these many small proto-galaxies. Just like we had proto-stars before we became a star, we have proto-galaxies. And these proto-galaxies would have included the halo stars, those globular clusters, just like that picture on the previous slide, just sort of lumpy, irregular, but then physics gets a hold of things. Gravity gets a hold of things. It starts to collapse and spin in a disk shape. And then after we have the disk, we keep forming stars. So later, why does it keep writing down there again? Later, stars are still forming. They keep forming in the disk. Remember, that is a feature of a spiral galaxy, is that it's forming stars, forming. It's not once and done. Stars keep forming in the disk. So we have this sort of chaotic picture of these protogalaxies coming together, these globular clusters, forming this disk with a supermassive black hole at the center of everything, and then star formation keeps going after that. So like I said, you'll have a video at the end here about which came first, the black hole or the galaxy, and then I have another short video that sort of shows a simulation of how this might have all happened. You'll also have several clicker questions today. This is one of them. In the disk of the Milky Way, stars are what compared to the halo? So, age of stars in disk versus halo. Okay, so what is some evidence for this whole thing that I've mapped out, where we have these protogalaxies coming together? Well, the main evidence is that we still see protogalaxies. Way outside of the Milky Way, there are these little galaxies that are orbiting around us, these dwarf galaxies. And we believe that they're old, leftover protogalaxies. So we have several protogalaxies orbiting the Milky Way today. Orbit, that's an O-R, orbit the Milky Way even today. Okay. And here are some examples, pictures here. You may have heard of some of these, especially if you've been to the Southern Hemisphere or live in the Southern Hemisphere. We have these things that we call the large and small Magellanic Clouds. We can't see them up here, up north, but they are big fuzzy patches on the night sky. Large Magellanic Clouds. They kind of look like fuzzy clouds, but when you look up close, you see they are these small, irregular galaxies. These are bigger than globular clusters, but small galaxies. They don't have a really defined shape. One other example is called the Sagittarius dwarf. Okay. So several of these are named. The Sagittarius dwarf, I point that out because we believe it is actually passing through the disk of the Milky Way right now. So those are 3 of them. But we think that there are 50 to 60 of these altogether. 50 to 60 total protogalaxies. And I should say, even though we think the Sagittarius dwarf is passing through the Milky Way right now, on the other side of the bulge from where we are, it's not going to cause a major disruption. Stars are really, really far apart, and even if they pass through the disk, they'll just change each other's orbits a little bit. Some of those stars will actually become part of the disk, but nothing for us to worry about over here. So this is the evidence that the Milky Way formed in this sort of scheme of things coming together. We think that these small protogalaxies, these satellite galaxies, have been around and just didn't get clumped in yet. But we think that many of those protogalaxies might join our Milky Way later, and that's kind of our last major point, is that the Milky Way is still growing. That Sagittarius dwarf, like I said, some of those stars will become part of our galaxy, is still growing. growing. That's kind of a cool thing. I mean, it's 13 billion years old, but it's still growing. How does it grow? By those proto-galaxies merging with us. Proto-galaxies merge with the disk. And my last point here is just to explain these pictures up here, kind of strange pictures. I'm going to have to scroll down, but what you're seeing here, this is the Milky Way. This is our night sky imagined. And this big thing over here is the Andromeda Galaxy. And what these pictures imagine happening is the merger of our Milky Way with Andromeda. Andromeda is our nearest spiral neighbor. So I'm going to scroll down here. I'll go back to the pictures at the end so you can look at it one more time. Andromeda is our nearest spiral neighbor, and we think that one day we will be one galaxy. That's a really long day away. We're talking billions of years. That we will eventually merge with the Andromeda spiral galaxy. So the universe is dynamic, just on really long timescales, right? Our galaxy is changing. It keeps changing. It will keep changing for billions and billions of years, right? So here it is. You can see this is what we might see in our night sky. When these galaxies merge, they'll become an irregular, a mixture. This will not, again, hurt us. It might change our orbit. A few stars might get kicked out of the galaxy, but we'll have more stars in our night sky. So that, in fact, we might be sitting in something that looks much more like an elliptical. We think that when galaxies merge, that they often end up looking more elliptical. All right, so a few more clickers before we end this video. Get your pencils and your minds ready. Here we go. These will all be on Moodle as part of the quiz. So what do we know about the Milky Way galaxy? Okay. Next, you're going to be doing a lecture tutorial on the Milky Way, on how big it is, and that's going to be coming up. You'll see an image like this in your book on page 135, and we're going to talk about how the sun right here is about 25,000 light years from the center of the galaxy. The whole galaxy is about 100,000 light years across. Once you've done that lecture tutorial, I usually do clickers at the end. I'm going to put them here. Okay, so you may want to do the lecture tutorial before you answer these. It's up to you. Imagine you could travel at the speed of light, starting from Earth. About how long would it take you to travel to the center of the Milky Way? Oh, there's more options down there. Make sure you get all those options. Okay, we did talk about that in the lecture today. And where is the sun located in our Milky Way galaxy compared to the center? So in the center, near the center, halfway, or near the outer edge. And you can refer to the picture in your lecture tutorial or that picture that I just flashed a couple of slides ago to answer that. All right, guys, that's it.